Hi, this is Mrs McTaggart. In this video, we are going to look at finding the length of an arc of a sector. So before I start, just need to make sure you know what a sector is. A sector is a shape that is part of a circle, like a slice of pizza. Now you should be familiar with half circles, quarter circles, things like that. Today we're going to look at more irregular fractions of circles. So it's called a sector. You have two options as well. You have what's called the minor sector and the major sector. And I think it's quite self-explanatory though. Minor means a small thing, so it's a small sector which I've shaded yellow. Major means big, so it's a big one that I've shaded white. And just be careful if they ever ask you for minor and major sector in an exercise that you're using the right angle. Sometimes to try and catch you out, we'd give you the major angle, but ask you for the minor sector. So it's just using that connection with subtracting from 360 to get the correct angle. So here is the formula for arc. Arc is basically like measuring the length of crust on your slice of pizza. It's a different word for circumference. The shape of an arc, if you think of the word arch, it's just an abbreviation of that. So arc is the distance. For example, I've got a wee picture here, the distance a pendulum swings. It's the length of your pizza crust if you were to measure it with a measuring tape. It could be the distance a clock hand moves, a certain bit around the clock, and I'll show you one about a clock hand. So here is the formula. It's quite straightforward. You have to memorise this one though. This is not given to you on the formula sheet, so you have to memorise it. Oh, I don't know why my pen's so fat. So you have to memorise it. And the thing to remember is the pi d bit. Pi d was your circumference of a circle. C equals pi d. Arc is connected to circumference, so it's pi d. Alright, and if you can't remember the difference between when to use pi d and when to use pi r squared, go to YouTube and Google circumference song and look for the one of the farmer singing. It's the easiest way to try and get it in your brain. You'll not be able to get the song out of your head. So the angle over 360 bit, that's you basically saying what fraction of the circle you're using. And it could be on calculator with a specific angle that will simplify, or for the majority of my examples, you are allowed a calculator. So in this question, I want to find the arc length of this minor sector. So I want the distance from here to here. So I'm going to start with the formula. So it's arc equals, it is your angle over 360, so my angle is 40, over 360 times pi. Now d for diameter, your diameter is this full length here, so it's another 7, so your diameter will be 14. Now when you go type this into your calculator, you've got a couple of options. I simply do 40 divided by 360 times by my pi button and then times by 14. You are allowed to also use 3.14. We won't mark you down for it. It's just a bit nicer though to use the pi button now that we're National 5. As I said, the other option is I type 40 divided by 360, but a lot of pupils in the class like to use a fraction button and just put it in with the one that comes up like that, with the two squares, and they just put 40 in the top, 360 in the bottom. But I'll be honest, it's quicker writing 40 divided by 360. Either way, you'll get an answer. Now, I haven't specified any rounding in these, so all my examples are going to be to 2 decimal places, and that will give you 4.886, so 4.89 centimetres, and that's to 2 decimal places. And that's it, really. So it's your angle over 360 times pi d. That's all we're doing. So make sure you've got the right angle. That's the easy bit. Make sure you've got the diameter. Okay, here's another one. It's a bigger sector. This time it's asking for total perimeter. Now watch out for that, because a lot of people will go in and just find the arc length and not get the perimeter. Perimeter of a shape is from start to finish. So if you started here and you were to walk all the way around the shape, you would do the arc, you would come back another 9, and you would come back another 9. So at some point my perimeter is going to be 9 plus 9 plus whatever I get for the arc. So I'm going to come back to that. So let's get the arc. So the arc length is your angle over 360 times pi d. Now 9 is your radius here, so your diameter will be double that, which is 18. And if you go to your calculator and type that in, you will get, bear with me, you will get 21.99. 991, so we'll set it to 21.99. So coming back to what I said about the perimeter will be your 9 plus your 9 plus your 21.99, and that gives you a total perimeter, oh my goodness, of 39.99. Pretty safe to say that that's really 40 centimetres. But I like 2 decimal places, so I'm going to leave it like that. So watch out, always read the question. This always catches people out in this one. Moving on, let's put it into a bit more context this time. So I mentioned a clock face. So here we have a clock face and we're told that the big hand is 8. So that means my radius here is 8. And I have to calculate the distance it travels in 25 minutes. So arc equals, it's your angle over 360. Now I don't know my angle, but I'm going to come back and get that in a second. Times pi times d. Now d will be double of 18, so 16. Now let's think about that angle. Your clock is divided up into 12 sections, and my big hand at the moment has travelled 5 of those sections. So I'm going to do 360 divided by 12, and that will tell me what one section is, and then I will times it by 5, and that will get me the angle of 150. So my angle in the centre is 150 degrees. And then if you go type that into your calculator, you will get 20.943, so 20.94 centimetres. And again, that's the 2 decimal places. Okay, so that was just a bit more of a context question, a wee bit more work to it and thinking. I've seen a similar question to this about like the Ferris wheel or spokes on a bike, something like that. Something that's got a circle that can be easily divided into sections. And then, of course, I always like to finish questions with a non-calculator one. It's always important to be able to do things like volume, trigonometry, arcs and sectors without a calculator. And they're all pretty similar calculations. So let's just go and do as normal. So it's going to be arc equals your angle over 360. So 240 over 360 times pi d. Now, without a calculator, pi actually gets used as 3.14. And it normally tells you that in the question as well. I just didn't put it in. So pi gets replaced with 3.14. My radius is 30, so my diameter here would be 60. Now, in any of these calculations, I try and drum it into pupils. You should not be doing long multiplication. You should not be doing big multiplication sums and then divisions. Something cancels out all the time. Now, the first thing we need to do is simplify down that fraction. Now, if I take off the zeros, 24 and 36 are in my 12 times table. So that becomes 2/3 times 3.14 times 60. Now, remember multiplications can be done in any order. So if I ignore the 3.14 just now, I can find 2/3 of 60. 60 divided by 3 is 20. Times it by 2 is 40. So this actually becomes 3.14 times 40. Now, to multiply any decimal by 40, I start by timesing it by 10, making it 31.4. And then I simply have to times it by 4. 4 4s are 16, 4 1s are 4, add 1 is 5, and 4 3s are 12. So my final answer is 125.6 centimetres. So actually, the only real sum I had to set down was a decimal times 4. That's all you shouldn't be doing. Shouldn't be doing long multiplication, shouldn't be doing divides and everything all over the place. It's all to do with this fraction. Normally the denominator cancels with a number at the end. So that's me. If you want, I've put up some examples that I use with my class here. We've got a mixture of arcs using a calculator and without a calculator, and answers there as well, and I'm 99% sure they're all accurate. So feel free to pause the video and try them, or screenshot it and go try some of these on your own. Thanks for watching, and I hope this has helped.